All right, hello, welcome back. We are done with the notes. We've finished chapter 4 and chapter 1 respectively. Um, Finished 1.3 notes yesterday. Today, plan will be to look through some FRQs, just kind of get you thinking about stuff you might see on the quiz over 1.3 they have tomorrow, or things that might show up on the test in a couple weeks here. So plan today will be to walk you through a number of FRQs. There's 5 FRQs here. That would take me 75 minutes. I'm not gonna have a 75-minute video for you here. My plan is to talk about big picture things, tricks to solve these problems, and things that are really important to solving them. I'm not going to tediously go through these problems one by one and write them all out. I'm going to show you the key. I'm going to ask you to do it on your own. If you're here in person, I'll grade it with you. If you're not, you might get on the Zoom call later in the hour to talk through some of these problems. So let's go ahead and get started. So quick reminder. You might be saying, how long do I take on an AP Stats FRQ? And the answer is like 12 minutes, 10 to 15 minutes. Let's shooting for 12, 10 to 12-ish, right in there. Some are going to take you a little longer. Some are going to be quick. And hopefully these are some of those that go a little bit quicker. So we have a simple random sample of 100 high school seniors. Bell was selected from some large school district. Gender of each student was recorded, and each student was asked a couple questions. Great. If you had a part-time job, and if the answer was yes, was it a part-time job only? Okay, well, fine. Those are reasonable questions, I guess. And we got the data, and this is on the grid below. Construct a graphical display that represents the association between gender and job experience. Some things that you need to not forget is that you're going to want a key, and don't forget to label your axes. Doing these problems, a common thing is to forget to label an axis and to forget to fill out your key. We're talking about side-by-side or maybe segmented bar graphs. I expect most of you will do side-by-side, but I don't know, try and represent the data. How can we see, okay, boys, I don't know, what are they doing? Girls, what are they doing? I don't know. And then on the back, write a few sentences summarizing what the display in Part A reveals about the association between gender and job experience for students in the sample. So a few things I will, almost slipped there. 4 students in the sample, this isn't true for all boys and girls. It's restricted to those folks. They're children. So you need to make sure you talk about both genders and all levels of job experiences. Talk about both genders need to be mentioned. Maybe comparisons at each job experience. You should talk about everything. Don't just talk about one half of the picture. Talk about both halves of the picture. That's actually 2/3. There's a part C to that problem that's a chapter 11 thing that we don't worry about until like March. You're going to see me in March, and that's fun to think about. Number 3, before the beginning of unit on frog anatomy. I think I gave you this on the quiz. I may have. They all blur together to me. You're going to talk about an assignment method for assigning the 2 groups of equal size that allows for statistically valid comparison, and you're going to talk about how self-selection might jeopardize. And I think we've done this, but I put this on here so you look at the scoring guide. Be sure to reference the scoring guide. That is the key. If you haven't noticed, I've the key's already shared with you. Hopefully you're trying this on your own without having looked at the key. Give yourself 10 minutes, try and do it, come back and look at the key and make corrections. So I think you might have a different graph than A. I think percent of gender. Yeah, I think the way they do it's a little goofy. I do it percent of experience category, but you can have a slightly different looking graph than they do, is my point. Talk to me, show it to me in class, show it to me on the Zoom call if you're not sure if your graph also does it. Part B, make sure you describe as they have, talking about both genders and job experience levels. And then notice, okay, this is how they're scored. All right, E's, P's, and I's. Take a look through that. E's, graphs drawn correctly, labels are provided. Oh, missing some labels, you get a P. Discusses percentages for both genders within each category. Great, you have to talk about both things. Didn't do part C. And it tells you how those are graded. And then the second part, I think we've seen this before, but I didn't show you the scoring guidelines. I'd like you to take a look at the scoring guidelines just to see what kind of detail is expected here. My gosh, that's a lot of detail. So take a look through that. You guys gave me things like this, but maybe not as much detail. So I'd like you to look at that detail, and you need to add some of that detail that you didn't have the first time through. That's why I included that question. So what have we seen so far? This first question, 2009. If you're not ever, without a key, you can always Google search 2009 AP Statistics Free Response Scoring Guideline. So this question here, what is this? This is a 1.1 sort of question. This question down here, talking about experimental methods, that's a 4.2 sort of question. Okay, cool. Next one, what do we got here? We got some box and whisker plots. That's going to be a 1.3 sort of question. So let's get into it. We're measuring concentrations of some contaminant in parts per million for 20 locations that were sampled in each of some 3 rivers. We're asked to compare the distributions. Compare the distributions. Okay, if you see distributions, you better know what you need to talk about. Can you write down the acronym? SOX, right? Hopefully you knew that. Shape, outliers, center, and spread. So compare means you need to talk about all 3, and you need to talk about SOX for all 3. Talk about the shape of all 3. You can kind of talk about shape. Talk about the outliers. Are they outliers? I don't know. Definitely talk about the center. Definitely talk about the spread. You can see center and spread. Shape, maybe part B gets to that. Part B asks you to construct a stem plot. Don't forget your key when you construct that stem plot. Part C asks to describe a characteristic that can be seen in the stem plot but cannot be seen in the box plot. Words like can and cannot, those sorts of big negative words, highlight those. So you're going to make that stem plot. If you make it right, there's something that will show up in the stem plot that will not show up on the box and whisker plot. Great. Key attached for that. You actually did it right. You're not just looking at the key. You paused. Pause. Do it. Give yourself 10 minutes. And then you come back and you talk about definitely center and spread of these 2. It talks about the shapes appear to be skewed right, roughly symmetric, and skewed left. You can kind of see that. They didn't, they made you talk about shape. They've changed since then, and shape would be hard to talk about here. Why? Because you don't know what the actual distribution is, but we're going to let them get away with that. So talk about shape, center, and spread, and then you've got your stem plot. What doesn't show up? Gap in the data. There's a gap at 6. Make sure you didn't skip the stem of 6. All right, so here's one actually you've seen before. This isn't a new one. It's in the key. Try and do it again, though. This is a, what is this kind of question? This is a, well, it's a 4.2 sort of thing. Lots of good definitions here is why I've included this. Lots of good definitions, and I don't think, I think it's just worth doing this problem all over again. You've seen it before. No surprises here. Just do it again. Look at the scoring guidelines. They're included. That's a good one. A lot of definitions. If you haven't figured out, this is definition heavy. Number 2. This is another 4.2 sort of question here about experiments. A lot of experiments. I got the last one, samples, don't worry. Describe a sampling method, the design, excuse me, not a sampling method, but an experimental design, and assess whether it could be double blind. When you're asked to describe a design, detail, 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 lots of detail. Don't just say the hat methods. Say what the hat method is. Don't just say, well, we're gonna randomly do something. How are you going to randomly do something? Could it be double blind? What does double blind mean? First, go back and ask yourself what double blind means. Ask if it could be executed in the problem. You've got a key for that one as well. And the last one, you can skip maybe one of those 4.2s, but this is a good question. This is a 4.1 question dealing with sampling methods. This is kind of some 4.1, and it's also got some 1.3. So I like this question. It really combines a lot of things. Okay, so we've got 25th reunion of some school. The folks that showed up said they had an average of $189,000 in income. Hot dang. And then the director of the Alumni Foundation said, holy cow, our members are making all this money. Look at that. What would be a statistical advantage of using the median rather than the mean? Statistical advantage is something that what does it allow us to see? Maybe better. So why would I want to see the median? What does the median tell me that the mean doesn't tell me? Or perhaps the mean is maybe not the best measure. Talk about why the mean isn't the best measure and why the median perhaps is a better measure. So part B may be different from the class as a whole. We may have a more detailed survey was planned to find a better estimate. Great, we got a couple methods. Which of the two methods would you select? Explain your reasoning by comparing the two methods and the effect of each method on the estimate. So compare, we need to talk about both. The effect on each estimate, is it going to be representative? I know I got an extra S in there, representative. Is it going to over or underestimate? Talk about what's it going to do. So make sure you talk in enough detail. That's an interesting problem, and there are some problems with those methods in part B, and you need to speak to them. So make sure you look at the key. I don't want to ramble on forever. You've got the problems. You've got me either in class or you've got me in person, online. So call into the Zoom call if you have questions over this stuff. I would say, well, got to do these, got to get these submitted for next time. These are good practice, but I've given you the key, so do it. Get in the habit. See you next time.